All right, hi folks. I've got the next section here ready for you, section 5.4. We're going to walk through the notes and we're just cruising through chapter 5. These YouTube videos, I think there's a maximum length and then they're too long to upload and I don't know how to splice them. So I'm going to go about probably, going to set my timer for about 15 minutes just to be safe, and then I'll probably stop it and then make another one. So I don't know how many videos that's going to encompass, hopefully just a couple. Hopefully this won't take any longer than 30 minutes, but there might be a little bit of that as we go on here. So nonetheless, let's get started. Section 5.4, read along with me. It says, by writing angle measures as the sums or difference of special angle measures, you can use these sum and difference identities to find exact values of trigonometric functions of angles that are less common. I know that doesn't mean much to you, but basically what we're doing is, if you look down here at example 1, it says find the exact value of each trigonometric function. What's the sine of 75? Well, there is no 75-degree angle on our unit circle. There's a 60 and a 90, but there's no 75. And early disclaimer, I realize you could just type in the sine of 75 and get that value on your calculator, but there's a distinct little blurb in the teacher's edition textbook that says have the students do it this longer way. It provides a slightly more accurate answer. They'll learn blah blah blah. So hey, go with it, jump through the hoops. We're gonna solve these, or we're gonna find these values by these new sum and difference identities today. So here they are. It's basically there's a sine sum identity. There's a sine difference identity right there. There's a cosine sum identity. And by the way, that's an alpha and a beta. Those are just random Greek letters that stand for any angles. There's a difference identity for cosine right there. And then you have your sum identity for tangent and your difference identity for tangent. So we have 6 new identities, and those are on your blue sheet. They are down at the bottom right of the front page. There's your sum and difference identities for cosine, your sum and difference identities for sine, and then I believe on the back, which I don't have uploaded here, but on the back would be your tangent identities. Now, if you want to know the backstory of how these came about and why these are actually true, in your textbook, page 336, the authors do a nice little job of developing this with the unit circle. It involves chords, it involves the distance theorem, and man, they just plow through it, and it is a little fascinating. It's quite fascinating, actually. I'm not going to take the time to share the backstory with you. We're just going to kind of trust that they work and really just get some work in with them for this year, okay? So let's start down here at example 1. It says find the exact value of the sine of 75. Well, when you think about that, and you think about what I read earlier, how could you represent this not so common degree with a couple of other more common degrees? And you think of 75 degrees, well, that's the same as 45 plus 30. So you could rewrite the sine of 75 degrees as the sine of 45 plus the sine of 30. And then what you have is you have something that looks like one of our identities here. You have a sum identity for sine. Alpha would be your 45 degree, beta would be your 30 degree. So you want to set this equal to, it's basically sine of your first angle times cosine of your second angle plus the cosine of your first angle times the sine of your second angle. So, and you just follow the yellow brick road. You just pretty much just kind of do it and follow the formula there. So this would be the sine of the first angle, which is 45 degrees. And it's times then, it's cosine. If you look at your identity up there, it's cosine of 30. Right, a little smaller than I am because I don't want to drift over here, but looks like I'm going to. So start over to the left a little more on your notes, or just write a little smaller. Cosine of 45 degrees times sine of 30. And then you can actually find these. You know what the sine of 45 degree is. That's the y-coordinate of the 45 degree angle, which is right there, rad 2 over 2. So you can actually get these on the unit circle because they're more common angles. The cosine of 30, well, where's your 30 degree angle? Right there. And the cosine is your x-coordinate. So that's rad 3 over 2. And then there's a plus sign. And then we have another cosine, but it's the cosine of 45 degrees, and that's the x-coordinate of the 45 degree angle, rad 2 over 2. And then we're back to sine with the sine of 30, which is 1/2 right there. Okay, and then just go ahead and simplify. You don't have to have common denominators to times. You just multiply top times top and bottom times bottom. So this would be radical 6 over 4. And this would be radical 2 over 4. And we're practically finished, except the fact that we're adding fractions together, and we do have a common denominator in place. So we might as well just go ahead and make this rad 6 plus rad 2 over 4. And that's your answer. If you punch this into your calculator, you get like something like 0.952, something like that. And if you actually took the sine of 75 in your calculator, you would get microscopically the same thing. And so you can kind of check your answer if you want to at the end by just kind of doing them on the calculator. But that's a good start. So we found the sine of a kind of a not so common angle by turning it into two more common angles. I'm looking at the next one here, cosine of 105, and there's a lot of different ways you could come up with 105, but I'm going to choose to use a difference identity since we already used a sum identity just to expose you to a difference identity. I know that 105 is the same thing as 135 minus 30, and that is 105. Or, you know, like I said, there's all kinds. You could have easily used the cosine of 60 plus 45. You could have used that. I'll put that in parentheses just as a, you could have done that. But again, I'm going to use a difference identity. So let's look up at our difference identity here at the top of our page. And let's see here. Got some residue I can get rid of there. Okay, so it's the difference identity, and so it's cosine, it's cosine cosine plus sine sine. All right, so cosine cosine sine sine. So this would be, I'm going to erase this part since I'm done with it now. Hope you're having a great day. Not a good day, a great day. This would be the cosine of 135 degrees times the cosine of 30, and then it's plus in between. It's actually the opposite of what you think it would be. Sine of 135 times sine of 30. Sorry, that wasn't the neatest writing I've ever used. And of course, you can stop the video at any time if I get going a little fast and you need to catch up. Cosine of 135, so that's the x-coordinate of a 135 degree angle, and I've located it right there. That's negative radical 2 over 2. And that is times the cosine of a 30 degree angle, which we already kind of worked with a little bit. That's radical 3 over 2. And then we have plus, and now we have the sine of a 135 degree angle, and that's radical 2 over 2. And that's times the sine of the 30 degree angle, which is 1/2. And again, these aren't difficult at all to put together when you get down to this point because they already have common denominators. All of your denominators up here are 2's. So it's kind of nice. This is negative rad 6 over 2. And we're going to add that to, it looks like rad 2 over, oops, I made a mistake. What did I do? What did I do wrong on that first blue part? The denominator should be 4. 2 times 2 is 4 on the denominator. And then, like I say, you can, since we already have common denominators in place, you can easily just go ahead and put your fractions together with your common denominator. And I'm anticipating that those problems shouldn't be too bad for you. I've given you one of each of these, one with sine, one with cosine, and I'm hoping those will be okay. If not, maybe you can go back, watch the video, you can read the section in the book. A lot of stuff you can do to help yourself out. You can Google the Khan Academy. All right, let's go over to the back page. Well, same thing here. Same thing, same concept, but now your degrees are in radians. And I suppose you could change these to degrees by multiplying by 180 over pi. You know, the way they did them in the book, they wanted you to get some practice with changing, you know, these radians into something that's on the unit circle. For instance, 7 pi over 12. I don't see that anywhere on the unit circle, right? 7 pi over 12. That's nowhere to be found. 7 pi over 12, right? But what if I rewrote that as, what if I rewrote 7 pi over 12 as maybe like 3 pi over 12 plus 4 pi over 12? Well, I know that's 7 pi over 12, right? And by the way, you want to, this problem over here is going to take a ton of space. We might even have to slip down the side. So try to leave as much space over here as possible. I would definitely fit most of this problem over here. Okay, so I could rewrite this as the cosine then of these two angles, and I can reduce. 3/12 is the same thing as 1/4. And 1/4 pi is the same thing as really pi over 4. So it's really pi over 4. And I know pi over 4 is on my unit circle. That's a good one. I can reduce 4/12 to 1/3, which is pi over 3. Pi over 3. And so now I have a sum identity for cosine now. So you can go back to the front, and the sum identity for cosine is the cosine of the first angle times the cosine of the second angle. And then it's actually minus. It's weird. It's backwards of what you think. And it's sine of your first angle, sine of your second angle. All right, there you go. And you should be able to look at your unit circle, and you should definitely be able to look up the cosine of pi over 4. I'll let you flip over and do that right quick. Look at your unit circle. What is the cosine of the pi over 4 angle? Well, that's the x-coordinate of the pi over 4 angle, which is radical 2 over 2. Why don't you flip over and see what the cosine of pi over 3 is? What is it? All right, 1/2. And go ahead and pause the video if you want to and find the sine of pi over 4 and the sine of pi over 3. Okay, the sine of pi over 4 is rad 2 over 2. And the sine of pi over 3 is rad 3 over 2. All right, so let's go ahead and simplify each side. We have rad 2. Whoops, lost my ink. Let's hope that comes back very shortly here. You've got rad 2 over 2 times 1/2. And that would be just rad 2 over 4 minus, and then you have rad 6 over 4. And the answer here would be, I don't care how you write it, you could write your negative first, I guess, negative rad 6 plus rad 2. All your answers kind of look the same. They end up kind of looking the same here on a lot of these problems, because they all end up being around 0.9, 0.9 something. So there you have it. Now leave yourself quite a bit of space over here for this one. This one turns out to be kind of a booger, actually. And be patient here, but I might give you one like this on the test. Tangent of 17 pi over 12. Well, think about what numbers add up to 17 that could reduce with 12. Like, I probably wouldn't pick, 11 and 6. Although 6/12 does reduce to 1/2, 11/12 is not on our unit circle. I'm telling you what I'm thinking. I'm thinking 9 plus 8 is 7. So I'm thinking 9 pi over 12 plus 8 pi over 12. And if you think of reducing those, I think we're money in the bank here. I think we would have 3/4, and I think we would have 2/3. So 3/4 pi plus 2/3 pi is actually the same thing as 17/12 pi. And I know 3/4 pi and 2/3 pi are on my unit circles. So here's what we're going to do. We're going to take the tangent of 3/4 pi plus 2/3 pi. Now flip your paper over and look at the sum identity for tangent. It's a little bit different than the sine and cosine. Okay? So what we do for this one, and go ahead and pause the video if you want to try it on your own, but this gets a little weird. So it's the tangent of the first angle. So tangent of 3/4 pi plus the tangent of the second angle, which is the tangent of 2/3 pi, over, and then it's 1 minus, and then it's just these same things again, but it's multiplied by each other. The tangent of 3/4 pi times the tangent of 2/3 pi. So take a second and let that marinate a little bit. We're taking the tangent of this sum, and there is a sum identity. I really should have put equals in between those because it's not an arrow. They equal each other. That's why it's called an identity, because those equal each other. But these are now easier to find. These are okay to find. What is the tangent of 3/4 pi? Well, remember, tangent equals y over x equals sine over cosine. So the tangent of 3/4 pi, if I'm looking at 3/4 pi on my unit circle, and you can go there if you want, your unit circle, you might want to scroll, or I'm not going to, oh, well, I could scroll. 3/4 pi. Where's my tangent of 3/4 pi? It's right over here. I can erase that other part. Oops, I just saw I'm at the 17-minute mark, so I'm going to pause this video and start again with the next video, okay?